So as we are looking at this lovely day, we are going to be doing deductive reasoning. So it's a little bit different than we've already talked about. And our primary thing is we're going to use two laws, the law of something called detachment and the law of syllogism. The first thing we look at is detachment and syllogism, and we panic because big words often are scary. However, what we're going to show you is that these are less complicated than you think, and you already use these laws even though you didn't know it. So by way of review, inductive reasoning, the fastest and easiest way to describe inductive reasoning is reasoning based on patterns. Based on patterns. That's the short answer there. Reasoning based on patterns. Now, however, if we want to get specific, we could say observe a pattern, observe the pattern, make a conjecture, and then test it. But if we're just doing a quick, simple thing, it's you see a pattern and you deal with it. So it's reasoning based on patterns. Today, what we're going to focus our attention on is what's called deductive reasoning. And this you already use, and it's reasoning based on laws. Based on laws or rules or whatever. In other words, someone tells you something, or even you discover something, and you build on it that way. By way of example, up here we've got these college students and we want to know what their names are. This is deductive reasoning. There was no pattern. You didn't go around and stalk this guy whose last name was Evans, or her name, and then try to figure out where she was from, and then try to connect the dots. You weren't stalking here. You're just told a bunch of information and you logically reasoned it. So most of the time, when people say deductive reasoning, they often say or mean logical reasoning. Now, technically, both of these are logical reasoning, but when someone says logical reasoning, usually they mean deductive. That means you take all the information you can and you stack them on top of each other and figure something out. You come up with a conclusion based on all this information. So we're going to be talking about two specific laws and then using them over and over and over and over and over again. All right. First things first. Yeah. All right, so the law of detachment is this. Notice, ironically, I don't know if it's kind of like Inception, where dream within a dream within a dream. Well, this is an if-then statement with an if-then statement inside of it. Right, okay. So here's what the law of detachment says. It says if P implies Q, so this is a conditional statement, if P implies Q is a true conditional statement, and I'm going to abbreviate conditional statement with is a true conditional statement, then, and P happens to be true. In other words, P happens. Let me put, instead of just true, let's say P happens. It's an event that actually occurs. Then guess what else happens? That must mean that Q will happen as well. Now, it sounds confusing, so let's summarize it as easiest as we can. In other words, keep your promises. That's what this is. You keep your promises. And a promise can go like this. Your parents might say, hey, for every A you get, I'm going to give you $25 every semester. So what's the conditional statement? If A, so you say if A, then $25, right? Then $25. You don't have to write this. So that's the statement. And since your parents said it, you accept it as true, right? So you come to with a report card and you have 4 A's. What's your conclusion? I get $100. That's keeping the promises, right? Your parents lay down a promise here that if this happens, then this will happen. You come and demonstrate that it happened. So that means this has to happen as well. Okay? Threats are the same way. Breaking the law is the same thing. If you wear scantily clad clothing, then you will go to the office and deal with it. Okay? You come in half naked. All right, what's going to happen? Off to the office you go, right? So it's not just theory here. It starts with a theory, but then something actually happens in real life. Okay, so let's see how this plays out. This can be described as this situation here. All right, so here we have, all right, so let's try that again. We've got this right here is my P and Q. So we all agree that it exists, right? So what the law of detachment says is here is a true conditional statement. P then Q. Then in real life something happens. And here's what goes. Oh, P happens. So what happens now? Q also happens. And when I say P happens, I'm not saying, thank you. On YouTube forever. All right, so notice it's actually about something occurring. P happened and Q happened. Q fell down as well. Okay, so all right, so here's your friend Jamal, right? Jamal knows that if he misses practice, whatever it is, let's say football, before a game, then he will not be the starting player in the game. Jamal misses practice on Tuesday, and he concludes that he will not, he can't start on Wednesday. He will not start on Wednesday. Now, there might not be a game on Wednesday, but he certainly can't start on Wednesday. This is good logic. Why? Because it's kind of like the promise of the coach. The coach made this promise, which might sound more like a curse because it feels like it's bad. No matter what, doesn't say why, it just says if you're absent, then you can't start. Doesn't mean you can't play, just means you can't start. And so he knows that he will not be able to start on Wednesday. Let's take a gander at example number 2. And it says this: if two angles form a right angle, then the two angles, whoa, there's bad stuff. Then the two angles, scratch out another, are complementary. If two angles form a right angle, then they are complementary. Because A and C are complementary, A and C must be adjacent. So it is true that we can come up with a counterexample, but let's also break it down logically. Let's see here. Here is my hypothesis. This is what we are calling P. Two angles form a right angle. Okay? Next. The next part is that the angles must be complementary. That's Q. So what does it say? The true statement says this, that P implies Q. That P implies Q. However, let's see what's this. This is what's happening here. Is complementary? Is that P or Q? Look, this is complementary is happening. It's actually Q. So where did we end? We're actually here. We're not starting at P and knocking down all the dominoes. We're just at Q and that domino's down. That doesn't mean anything about the previous dominoes. The dominoes before might be down, or just this one got knocked down somehow. Okay? So, is this a good use of logic? And the answer is no, because Q happened, but not necessarily P. P may have happened, but we don't know. All right, this next one is called the Law of Syllogism. Great word. All right, so the Law of Syllogism says this. Again, it's inception. We have an if-then statement with if-then statements built in. So that's why I'm using the QRs and the QRs and the PQs here. So if P implies Q and Q implies R are true conditional statements, then P implies R is also true. So what would this be called? One way to just simply call this is the transitive property of logic. The transitive property of logic. Or another way to consider this is to consider it as the dominoes. So here is your first one. We're going to call this the P. Then we have a Q. And next, oh look, we have an R. So what happens? What's my now conclusion? Not only, so if P happens, it'll go to Q, and then if Q happens, it'll go to R. So simply put, I can just say P implies R. I can skip the middle step because that's embedded deep inside. So let's look at an example of the law of syllogism. If a bird is the fastest bird on land, then it is also the largest of all birds. Next, If a bird is the largest of all birds, then it must be an ostrich. So what does the law of syllogism say? It means I can connect fastest bird to ostrich. If a bird is the fastest bird on land, then it is an ostrich. And there we go. Notice, just for the sake of syllogism here, I'm deleting the large part. I'm just connecting the fastest to ostrich. Example number 4. If the sun is shining, then we will have a picnic. If we'll have a picnic, I'm going to make sandwiches. If I make sandwiches, I'm going to eat sandwiches. So, what is my new statement? So finishing this one up, if the sun is shining, then I will eat sandwiches. Notice, the sun is shining is P. Having a picnic is Q. Making a sandwich is R. And eating the sandwich is S. So we're doing an extended version of this. We're going from P to Q to R to S, and we're just skipping over everything in the middle. Then I eat sandwiches. And most specifically, mayonnaise sandwich with mustard and ketchup mixed in all together. And then any kind of meat except for that really disgusting meat. What's that called? Bologna's good. No, Spam's awesome. That other one.
Moldy meat.
Yes, there you go. And cheese. Most cheese is good. I will each learn to spell. Soissons. Eat sandwich. A sandwich. In fact, I would probably eat more than one sandwich. We're going to take this to the next level by saying that sometimes we can have both things happening at the same time, right? So let's look here. Notice we start way over here, and it's like the P is way over there, P is way over there, and then it goes P, Q, R, S, T, U, V, W, X, Y, Z, all the way there, and then all the way to whatever letter, we'll just say Z. So when I make this go, so notice that this right here, the setup is the law of syllogism. That's the setup. It's still a theoretical. If P, then Z. Now, when I put the law of detachment in there as well, this is what happens. Then I actually knock down P, boom, goes all the way to Z. So example number 5. What can you conclude from this given information? So we read each part. If you live in Athens, then you live in Greece. If you live in Greece, then you live in Europe. Now, some guy named Nick lives in Athens. So what can you conclude? And by the way, conclude means when all is said and done. At the very end. Not the next step, not the step after. It's the very, very, very end. All right, so our conclusion here is that Nick lives in Europe. Lives in Europe. That is the conclusion. That's the farthest you can take it. That's what conclusion means. The farthest you can take it. He lives in Europe. Okay, based on these statements. Now there are other statements that you can pull in, talking about economy, and then you can, make other deductions from that. But just from this information right here, that's the farthest that we can take it. All right, so what about this next one? What can you conclude from the given information, and what's our reasoning? If a river is more than 4,000 miles long, then it's longer than the Amazon. If a river is longer than the Amazon, then it's the longest river in the world. The Nile is 4,132 miles long. Is that the Nile is the longest river in the world? The Nile is the longest river in the world. And let me spell that right. River in the world. It's also one of the weirdest because it flows south to north. And most rivers flow north to south. In fact, almost every other river on the planet flows that direction. Almost every other one. I honestly don't know other ones. Is the longest.
Why does it travel the way it does?
All rivers